Hello, Algebra 1. Today we're looking at section 4.3, division properties of exponents. And this is actually going to wrap up all the properties of exponents. So we'll be moving to other topics pretty soon. Well, one thing I want to make clear is if you ever get stuck and you're like, man, I don't know what property to use, you can always expand these exponents out, these powers out, and then divide them, individually. So I'll give you an example. A to the 7th, if you expand that out, that'd be a times a times a times a times a times a times a. A multiplied 7 times. And then that would be divided by a to the 5th, which is a times a times a times a times a. And then you can say, oh, well, a divided by a is 1. 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 And you're left with 1s multiplied by a times a, which is a squared. Well, that's kind of a chore to do. So instead, what you can do is you can see pretty readily that 7 minus 5 gets you 2 as well. And that is, in fact, the shortcut here. That's the quotient of powers property. You subtract the exponents. So let's use this. The long story is you're going to do 9 minus 2. Notice your result always goes on top. It's always by itself. It's not in the denominator. But then 9 minus 2 is 7, so a to the 7th is your answer. If you have negative numbers, it doesn't matter. You just want to be careful with it because it's going to be 3 minus a negative 2, which would actually become plus 2. So it'd be 7 to the 5th. And then punch that into your calculator, find out what you get. So 7 to the 5th power. And I got 16,807. All right, and then it can get more complicated. And yeah, I was talking in class today that this kind of feels like a video game where you got to face different opponents, and then eventually you get to, I don't know if I'm surely not the only person, but you get to the boss, you get to the main bad guy of the level before you can go to the next level. So I feel like that's kind of what we're doing today. You start off with kind of the easier one and the next one. I may think of that in every lesson, actually. All right, so then right here, be careful. 3 and 9 are not exponents. They're just numbers. And they reduce. They reduce to 1/3. So I have a fraction that I'm dealing with here. So I'm going to start thinking about numerators and denominators for the rest here. This x to the 3rd and this x to the 1st, subtract the exponents, and the result's going to go on top. This y to the 2nd, y to the 5th, subtract the exponents, the result goes on top. But then if you'll recall, a negative exponent moves to the bottom, so we'll leave everything where it's at that doesn't have a negative exponent. But then we'll move the negative exponent power to the bottom and remove the negative. So this is what we get. A lot of teachers don't like you leaving the 1 there. I'm not a big fan, but it's okay. But yeah, you could, 1 times x squared is just x squared. So it would be x squared over 3y to the 3rd. And then on this next one, you could multiply straight across is what I would think about doing first. You could reduce these, the division first if you wanted to. I mean, there's no rule saying you can't do that. But I'm in the habit of multiplying across first, getting it to 1 fraction and then dividing. And if we multiply across, we're going to get 20 x to the 6th, y to the 4th. 5xy squared. And now we can divide. 20 divided by 5 is 4. If we have x to the 6th divided by x to the 1st, subtract, you'll get x to the 5th. And 4 minus 2 is 2. And we're done pretty quick. All right, so now the boss on this level. So we've got a few things going on here. It doesn't look as scary as this one, but I think it is a little more scary because we have negative exponents from the beginning, so that's kind of interesting. I'm still going to do the same sort of idea. I'm going to multiply straight across, and let's see if we can defeat this guy. All right, so we've got x to the negative 3. I'm going to leave it alone. Then I'm going to combine these y's together. And since we're multiplying straight across, that's just going to be adding them. On the bottom, combine the x's, add them. Leave the y alone. And now what we can do is we can divide. And when we divide, we subtract. So I'll do negative 3 minus 6, negative 2 minus negative 3. And I get x to the negative 9th, y to the 1st. Then that moves to the bottom, and I get y over x to the 9th. And I think I've done that right. Oh, I should probably slide that up. Okay, so I think, yep, I'm checking my other notes, and yes, we defeated the last boss on this level. So let's move on to the next level. The next power property is the power of a quotient property, and it's just like the power of a product property. It's the same deal. The power of the product property, we described it as distributing, and we'll do the same thing here. Again, if you ever forget this, just write out a over b times a over b times a over b 3 times, and then multiply straight across, and you'll find out, oh yeah, the exponent goes to both of them. So you can find that out pretty easily. So yeah, a quotient raised to a power, distribute the power to each exponent. Or you could think of it as to each base, you know, depending on how you want to think about it. Okay, so like on this first example, the 3 goes to each base. It'll be 4 to the 3rd, 3 to the 3rd, and then you can punch those in your calculator. And I get 64, and 3 times 3 is 9 times 3 is 27. And what's cool about it is, basically, before you do the exponents, if there's nothing that reduces, it's not going to reduce after you multiply them out, which is kind of cool. So yeah, 64 over 27 is your answer. X to the 7th over y to the 7th is your answer. 1 to the negative 4th over z to the negative 4th is not your answer because you're not done yet. Negative exponents make reciprocals. So this is going to move downstairs. This is going to move upstairs. We're going to get z to the 4th over 1 to the 4th. And 1 to the 4th power is just 1. So what we're going to have is z to the 4th over 1, which is just z to the 4th. All right, and then let's move on, facing more and more increasing difficulty here. Okay, so this 5, don't forget, it goes to every base, including the 2. So it'll be 2 to the 5th, x to the power of a power makes 20, y power of a power is 15. And then 2 to the 5th, I think is 32. Let me double check. Heck yeah, so it's 32 x to the 20th over y to the 15th. We're done. We don't have multiple bases that are the same. We don't have negative exponents. We don't have 0 exponents. We're done. This one's kind of a similar thing. The 4 goes to everything. 2 to the 4th, a to the 12th, 3 to the 4th, b to the 8th. And we're done. We just need to evaluate 2 to the 4th power, which is 16, because 2 squared is 4, and then double that. So, oh, wait, yeah. 16. Oh yeah, and then multiply it, I should say, together. So you get 16 a to the 12th over, and then 9 times 9 is 81 b to the 8th. Cool. And on this one, ooh, we got negative exponents, so this might get interesting. So power of power, you get 15. That's nice. 2 to the negative 5. B, power of a power, you get negative 10. Okay, so the 8 to the 15 does not move. The 2 to the 5th is going to jump out front because we put the numbers out front. And the B to the 10th, we'll just put it behind it. So notice the 8 to the 15 did not move. Those joined it. Those moved up because their reciprocals were needed. All right, and then we saw that earlier. Yeah, 32. And now, class, we're ready to face the boss of this level. All right, so here's the boss, and it's looking pretty scary, looking pretty intimidating. But we realize that to defeat the boss, we just got to go step by step. We got to break it down, and then we should have it defeated. So I'm seeing right here, this 3 can go to a lot of places. It's going to go to the 2. It's going to go to the 3. It's going to go to that 3 and make an exponent. But what's also going to happen is this negative is going to get the 3, which is kind of an interesting idea. I like to think of it as negative 1 to the 3rd power. The reason I write that out is because sometimes you'll have an even exponent, in which case it'll become positive. Right now we got an odd exponent. It's going to stay negative. But I like for you to make that decision. Is this going to be positive or negative? And it's going to be negative. We're going to have negative a to the 6th power of a power over 3 to the 3rd b to the negative 9th power of a power. And then we're going to multiply that. We're going to do the 2 over here as well. 2 squared a to the negative 8 b to the 8th. Okay, we've got a lot going on here. I think we're about ready to multiply straight across. But let's go ahead and evaluate this as well. 2 squared is 4. 4 times negative is negative 4. A to the negative 2nd. Add those exponents together. On the bottom, 3 to the 3rd power is 27. And then we're going to have 27 b to the negative 9. Oh, no, we'll combine the b's together. We'll get b to the negative 1. Negative 1. Whoops, going the wrong direction there. Negative 1. Okay, and yeah, we're going to, this doesn't reduce. Yeah, and you can check that in your calculator, but it doesn't reduce. So we're going to leave it as negative 4 over 27. But then the b is going to go up top, b to the 1st power, don't have to write it. And the a squared goes to the bottom, and we've defeated the boss of this level. Yay. All right, so you got some practice. I would definitely recommend doing the practice. Have a good day.